Now let's move to the paired t-test. So our first objective is going to be analyze if a paired t-test was appropriate for analyzing a specific endpoint. Within a journal article. Remember, if a crossover design study or a pre-post study is used, the patients in the groups are going to be related to each other. This is going to violate the assumptions of the first type of t-test that we talked about. So now we're going to use something called the paired students t-test. The pair students t-test uses repeated measures, and this is going to reduce error and increase power. And we'll see that with very similar data from our first example, we'll actually get a higher t-statistic. The higher this t-statistic is, the more likely you will reject the null hypothesis. As far as assumptions go with the paired t-test, the only difference in assumptions, and I'll type this out, the difference in assumptions is assumption number 2 we talked about before, and number 5. And these two assumptions are replaced by the assumption that dependent variables are associated. Versus before they had to be independent and the groups had to be mutually exclusive. The paired t-test is very similar to the normal t-test. The one difference is that when we calculate the test statistic, it's going to be a little bit different. However, we need to go through the same process as before. So now let's do another example. We'll use a very similar example to last time. So we are testing a miracle weight loss drug versus placebo. Patients are going to be randomized to either receiving the active drug or placebo for 1 week. Then they will enter in a washout period, and then they'll be put on the opposite, either placebo or active drug. So this is going to be a crossover study. And we'll have a total of 41 patients. Remember that these patients will be the same patients in both groups. And what we really care about with the paired t-test is the difference between the two groups. So let's say we had a mean difference of 8.5 kilogram weight loss, the same as last time, and we'll say our standard deviation is 3 kilograms. Once again, we have a colleague that recommends that we use the paired students t-test, so we want to make sure no assumptions are violated. To quickly get through the assumptions, this is a continuous type of data. There's still enough patients that we can use the central limit theorem to assume normal distribution, and the standard deviation is not greater than the mean, and the standard deviations aren't significantly different from each other in this case. So we meet the assumptions, and the fact that it's a crossover study and we're using a paired test makes the assumption that the groups need to be related also met. Next, remember, we will state our null and alternative hypothesis. Again, the null is going to be that the miracle drug has no effects on weight loss, and the alternative hypothesis is that the miracle drug has an effect on weight loss. Our next step is to specify the alpha. We'll set the alpha again at 0.05, and the next step is to calculate degrees of freedom. In this case, our sample size is 41, so since there's really only one group of patients, it will be 41 minus 1, which is equal to 40. And we're back at our t-table. We'll be using a two-tailed test with a alpha of 0.05 degrees of freedom. It's going to be 41 minus 1, so we need to go down to 40 in this column. And our value here is going to be 2.021. So our critical value is 2.021. And now we just need to calculate the statistic for the paired t-test. So in this case, the t is equal to the mean difference, and so that's going to be the 10 minus 1.5 divided by the standard error of differences between the groups. Remember, standard error is simply calculated by taking the standard deviation divided by the square root of the sample size. So in this case, we can take the standard deviation of differences and divide it by the square root of the sample size. Our sample size was 41, so let's write this calculation out. So it would be 8.5 divided by our standard deviation, which is 3, divided by the square roots of our sample size. We can just use n as our sample size. And if we do the math, the value comes out to be 18.14. And that value is greater than the 2.021, which means we're going to have a statistically significant result. Our next video is going to be going over one versus two-tailed hypothesis testing.